Hello, yes, we have a problem on the board. So on capacitance still, let me read the question. The diagram below shows three capacitors, C1, C2, and C3 of capacitances 2 microfarad, 6 microfarad, and 3 microfarad respectively. The potential differences across C1, C2, and C3 respectively are A. 4 volts, 6 volt and 2 volt, 2 volts, 6 volt and 4 volt, C. 6 volt, 4 volt and 2 volt, D. 6 volt, 2 volt and 4 volt. JAM 2001. So let's solve this problem. Now, looking at the diagram, we're given a diagram on the board. It looks like parallel arrangement. It is not parallel arrangement of capacitors. It is actually in series. Okay. Now, if it were to be a parallel arrangement of capacitors, they are supposed to meet at this end. The three capacitors are supposed to meet at this end. Okay, showing that they are on top of each other. There should be a connecting point at this end. But if you look at what we have, there's nothing like that. So it means that this is what? Series arrangement. Use your inner eye. Turn this thing around. Turn it. Turn it. Okay? It will make sense. Alright, so please don't get it twisted. Don't mistake series arrangement for parallel. Because if you do that, of course, you will get an answer, but a wrong answer. So if you have this kind of problem, the first thing I would advise you to do is to find the equivalent capacitance. The total, the combined capacitance is the first thing you need to find before any other thing. So let's do this. So we have our combined solution. So we have 1C. The formula for series is what? Thank God they have even labeled the C1, C2, C3. So it's going to be equal to 1 over C1 plus 1 over C2 plus 1 over C3. So substituting, we'll have this 1 over C1 is what? 2 microfarad plus 1 over C2 is what? 6 microfarad. Then C3 is what? 3 microfarad. As usual, let's keep this one aside and find the LCM of 263. Are you sure you can find the LCM of 263? Just in case you don't know, let me do this. 2, 6, 3. 2 here, 1, 2 here, 3. 2 cannot go here. The next available number that will go is 3. 3 here is what? Of course, 1 is coming down, 1, 1. So 2 times 3 will give us 6. So we have the LCM. Okay, let me bring it down. So we have 1 over 6 is equal, C all over 6. 2 into, let's drop the microfarad, we'll put it back when we're done. So 2 into 6, we have what? 3, 3 times 1, 3. Plus 6 into 6, how many times? 1, 1 times 1, 1. 3 into 6, how many times? 2, 2 times 1, 2. So let's add them up. 3 plus 1, 4. 4 plus 2 is 6. So we have 6 over 6. So we have 1 over C is equal to 6 over 6. Okay, and 6 over 6. What do? Let's cross multiply. So we have 6 is equal to what? Is this 6C? We are finding C. So we divide both sides by 6. We divide both sides by 6. So if we divide both sides by 6, we have 6 divided by 6. 6C divided by 6. 6 we cancel 6. 6 we cancel 6. We have 1. So our C is equal to 1. So permit me to wipe this side. We have gotten our C to be 1. Okay, so that's one of our parameters. We have found the combined capacitance to be what? 1. Now we can do other things. And we are given V to be what? 12. Now remember, another thing you need to know is that for capacitors in series, they have the same charge. So we don't need to be looking for Q1, Q2, Q3. The charge is the same. Okay, but the potential difference is not the same. The potential difference is not the same. So it means you'll be having something like this. Let's say this is the point for this. Let's say this is the point for this. You have from here to here. Let me complete their sketch for them. So you'll be having V1, V2, and then V3. Is that okay? So let's do this. Let's find the charge. We know that Q is equal to what? CV. So we have C to be 1, and then we have V to be 12. Okay? Remember, we didn't put our microfarad, so please. So we have this to be what? 12. Charge is in column. Okay? So, what do we do next? We have found that, so we are looking for the potential difference across C1, C2, C3. So let's do this. So we have C1 from this formula. If you make C the subject of the formula, okay, divide both sides by V to make that the subject of the formula. You have C is equal to Q all over V. Okay? No, actually V. So we have V1 is equal to this, right? Is that correct? We actually wanted to make V the subject of the formula. So we divide everything by C. So we have C is equal to Q over C. Okay? So if we have this, Q is equal to 12. Divided by C, we have 1. We have 12 volts. 12 volts. Then V2 will be equal to what? Q all over. I mean, this is C1. Okay? I hope I didn't mix things up. Yeah, I mixed things up. This will be 2. So we have 6, right? Okay? So we have V2 is going to be what? Q all over C2. So we have Q will be equal to 12 all over what? 6, which is equal to 2 volts. Then V3 will be equal to Q all over what? C3, which is equal to what? 12 all over 3. Okay, so 12 divided by 3 will give us what? 4 volts. So we have gotten our answer. So let's check the arrangement of the question. C1, C2, C3. So it's serially. So we have our answer to be what? 6 volts, 2 volts, and then 4 volts. So which one does it blend with? You have to arrange it, since they said for C1, C2, C3, it has to blend in that order. You don't swap them. So let's see C1, C2, C3. So let's see 6 volts, 2 volts. This one is not the correct. 6 volts, 2 volts, no, this is not correct. 6 volts, 2 volts, and 4 volts. Yes, this is our option. So please, you make sure you arrange it the way they asked you to answer the question. I'm still Bukola Joseph, and please pardon me for the distractions. Still Bukola Joseph, the physics enthusiast. I hope you enjoyed today's problem 7. Bye.